Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Hello, everybody, and welcome to Pepperl+Fuchs Plugged In. Today I have Eduardo with me. Eduardo, how are you today?
I'm doing pretty good, Helga. Thanks for having me on today.
Not a problem. Thanks for coming. Eduardo, we will talk about two different topics. We're going to have a little break in the middle. What is the topic that we're going to start out with today?
So today we're going to start out with a lesser known issue. It's a sort of a monster that plagues a lot of our customers.
That sounds
Wait.
Yeah, what is it?
Do you hear that?
No.
You don't hear anything?
No.
Hold on, wait.
There it is. There it is.
You got it.
Okay. I got it.
I think that monster, it's electrical noise. Could be coming from anywhere inside the room, could be your laptop charger, could be the fluorescent lights above us, but it's sort of a boogeyman for us.
And of course, you and I didn't hear electrical noise. We heard mechanical noise.
That's right.
Yeah, but machinery is impacted by electrical noise, and it's not a good thing because it messes with signals.
That's right. Yep. Electrical noise, it can disrupt signal disruption. You can imagine the problems that can cause on a machine or on a controller or any application that our customers face.
So, of course, we wouldn't be here if all we had to do was to complain about electrical noise. You have a solution. You have a suggestion how our customers should be dealing with electrical noise, or rather, how they should set up their system so that they are not being plagued by electrical noise. Is that not right?
That's right. There's a few basic things, a few basic techniques that can really help mitigate the scary effects of electrical noise that our customers see.
Okay, and those are?
Well, first, it starts with having the right hardware. You need the appropriate types of cables or connectors that can be installed in an area with electrical noise.
Let's start with a cable. So what makes a cable suitable for being used in noisy environments?
The first is it usually will be a shielded cable.
Okay, and tell us what shielded means.
Shielding, basically, it's just having some sort of metal jacket inside of a conductor that mitigates the effects of noise.
And there are a couple of different ways of accomplishing this.
Right. Regarding shielding inside of a cable, there's two main types of shielding. The first is braided shielding, that it doesn't fully cover the conductor. It does a lot of things. It gives the cable some mechanical reinforcement, but also has some electrical noise mitigation.
Okay, and what else can we do?
Another option could be a foil shield. That's more commonly used for communication, especially Ethernet.
All right. So now that you've told us what construction there is, how does shielding work in the first place? Why does it help when you have a noisy environment?
Well, basically, what shielding does is it causes an induced current inside of a conductor through another source, through a source of the noise, which causes a magnetic field, and that induces the current in a conductor. And that's a problem when you're relying on a controller or a sensor to read or send very precisely timed signals. So if a conductor is in an environment with noise, you can get charges, you can get current through the conductor, and the controller or computer will read that as a signal.
I would imagine that's particularly troublesome when you talk about small analog signals.
Definitely. Small analog signals, they're very, very precise, and whatever is reading it, it's really relying on the precision of that signal.
Okay, so we have this field, we have this noise, it kind of hits the cable, there's a shield. What happens now? There's signals induced on that shield. What happens now?
So the shield, what it does, it basically takes that charge and it kind of smoothens it over the length of the conductor. So rather than having one spike here, one spike there, you get a consistent charge across the whole conductor, and that basically keeps the amplitude of the charge very low.
Okay, okay. Is it not true that these shields are frequently connected to a well-defined ground to get rid of the charge entirely?
Right. Proper shielding, it has to have a good source to ground.
Okay, good. All right. So let me get to my note sheet here. I had a couple of other things that I wanted to ask you about. Eduardo, there's another technology, another method to deal with noise, and that's twisted pair. So what can you tell us about that?
Right. So that's a common technique used in communication cables. Basically, they'll have two conductors and sort of twisted in a coil together. And what that does is it reduces the effect of noise on those two conductors because they're electrically coupled. So because of that, the effects of noise are reduced on that pair.
Yeah, in fact, Eduardo, AS interface is a technology that depends on only the difference between two signals. And so having those two conductors close by, like in a twisted pair, now AS interface is not twisted pair, but like in twisted pair, means that any type of noise would get equally on one as on the other. And so therefore the difference is zero.
Right.
So that's that effect.
The effects of noise will be the same on both conductors and
thus non-existent.
right, exactly.
Yeah, good. I tell you what, as always, Eduardo, I want you to think about 5 words that describe the topic we're discussing. And while you think about it, I try to summarize what we've talked and what we've learned. So noise is everywhere. And there are multiple ways of dealing with noise. And the most common way of dealing with noise is to have proper shielding. Cables can be shielded using a foil shield, which has very good coverage across the cable, but is mechanically not particularly strong. Or you can have braided shield, which is mechanically very strong, but doesn't have the same coverage. Now, of course, it's possible, and it's frequently done, to have braid and foil shield. Drives up the cost, but ultimately ends up with the highest quality. And another technology that's out there, mainly used in communication for differential signals, is twisted pair.
Alrighty.
Anything to add?
Yeah, definitely. My 5-word phrase is don't be afraid of noise. It's hidden, it's invisible, it can cause problems that you can't predict, but don't be afraid of it because there are easy ways to mitigate it.
Very good. Thank you very much, Eduardo. We're going to take a short break and then we come back for our second topic, industrial connectors. So, welcome back. Eduardo, this is the second part to our podcast today. And we started out talking about cables, but of course, cables are frequently connected to connectors or part of a construction with a connector. Let's talk about industrial connectors, the types that we see in factory automation, in not building automation, I want to exclude that, but also in mobile equipment and related fields. So tell us a little bit about what types of connectors are out there that we see a lot.
There's so many different kinds that you see, but really one of the most common ones is the different types of circular connectors that you'll see, sort of like the M12, the M8, the same types of circular connectors that you'll see on a lot of our sensors and a lot of our products.
There is also, has been historically commonly used, a 7/8 inch connector. What can you tell us about that one?
So that one, it's really more for the American market. It's not as popular worldwide or overseas in Europe as the M12 or M8s are, but that's typically used here in the Americas.
And it is being gradually replaced by more modern technologies.
Right. I mean, just due to the global economy, machine builders standardizing on different products, it seems like M12 and M8 are here to stay.
Okay. So M8 is a relatively small connector. Why are there different connector sizes in the first place?
Well, really, it depends on the use. And some users might require a more robust connector that's carrying a lot of power. For us, really, we're dealing with usually sensors, switches, camera systems that are usually running on low voltage, not super high current. So we can get by with the M12 and the M8 circular connectors.
But you say we can get by. There is an amazing M12 technology called an L-coated connector. Can you talk to us about that one?
So that's a special type of M12 connector. It's basically for higher power applications, for higher power uses, similar to a 7/8 connector, but
even higher current than 7/8.
Even higher current. Yep.
Yeah,
yep.
It's amazing. So since we briefly threw in the word M12 L-coated or M12 whatever, tell us what type of coating there is on the M12 side.
On the M12 side, there's various coatings depending on what that connector is used for. And probably the most common or the most widely used is the M12A coated. It's a very simple geometry. It has just one little notch, but basically you can only install it one way just based on the geometry.
Okay, so that notch helps you to make sure that plus goes to plus, minus goes to minus, and so forth.
Exactly. Yep. You can only install it one way, no matter how hard you try.
Okay. All right. What else is there? What other coatings do exist?
So that's the typical types of connectors you'll see for a sensor or a basic application where you're just transmitting high or low signals. For more complex applications where you have signal transfer or data communication like Ethernet, you have to use a different type of connector, so you don't accidentally connect the wrong connector with a Ethernet connector.
Yeah, that's the whole point of coding. It is to help a user avoid incorrect connections.
That's correct. And for Ethernet specifically, they like to use the M12D coded, and that particular coding is for 4-pin Ethernet, and it's a M12D coded connector.
Okay. Now, some of our listeners may have heard of another M12 coding style called a T code. What can you tell us about that?
So an M12T code, it's used for the same types of applications as an L-coded, but it's a little bit more antiquated, and it's on its way out, the T-coded.
Okay, you see it less frequently. It also doesn't quite have the same performance as the L-coded, if I'm not mistaken.
That's right. On an L-coded, you can run a lot of power through it. You can run up to 16 amps on an L-coded, while a T-coded, it's around 12 amps.
Okay. All right, that's definitely a huge difference. Now, briefly talk to us about some other, maybe you could call them more specialized, like Amphenol and Deutsch connectors. What is the deal with those?
So those types of connectors, the Deutsch and the DT and the Amphenol, those are really popular with mobile equipment customers. They love that type of connection because it seals very well. You can install it very quickly, and you even get a nice like haptic feedback when you connect it. You feel and you hear a little bit of a click.
Oh, that's a good point. So, of course, on an M12, that's not necessarily the case. It's a screw. It's a nut that you have to tighten. So how do you know that you've done it properly on the M12?
On the M12, or at least on the Pepperl+Fuchs M12 connectors, there's a visual indicator just by looking at the side of the connector. If you can see the green contact carrier behind the nut while you install it, and the nut is nice and parallel, nice and even, then you know you've made a nice connection and it's nicely sealed.
Okay. Now, we also do offer, and our connectors support this, we offer a screwdriver-like tool that's a torque tool that allows you to make sure that you're torquing down the nut to the proper value.
That's right. Yep. It's basically a hex screwdriver, and it has a special M12 bit. And yeah, exactly like you said, it's a torque screwdriver. And once you tighten it enough to the appropriate torque, it'll click, and you hear it, you can feel it. And that's how you know that the connection is nice and tight.
Oh, very good. All right, I think it's time for me to try to summarize and for you to again think about a 5-word phrase. So Connectors come in many, many styles. In factory automation, M8, M12 with various coatings are the predominantly used connectors. To name a few, the A-coated is typically used for low voltage DC signals. Sensors typically have that type of connector. Then there's an L-coated version, which is used heavily on the power side of I/O link masters and I/O modules because of their ability to carry a good amount of current, in fact, 16 amps. There is another competing, slightly less performing T-coated version that is kind of dying out right now. And for Ethernet communication, there is the so-called M12 D-coated. And there are many, many other versions, 7/8, and X-coded and RJ45 that we didn't cover. But I think especially RJ45 is probably quite well known. We all use it at home when we plug in our routers into our switches and set up our home network. So those are relatively common. Anything else to add, Eduardo?
Really, just the last thing is just, I think you summarized it pretty well. Really, the last thing is just a phrase I have for you guys. It's application specific and readily available. The different types of circular connectors really just depends on the use, and that's really what it comes down to for circular connectors.
Very good. Thank you very much, Eduardo. I hope everybody out there finds this an interesting topic. Picking the right cable is important. Picking the right connector is important. And as far as I understand it, we have quite a few of those.
Oh yeah, we have cables and cords for all of our target markets, and we have a huge variety of them.
Great. Thank you very much, Eduardo. Take care. Bye-bye.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.